June the 27th. So we're working on confidence intervals. So as you can see, we've got confidence intervals today, and then we're going to move into a new phase and we'll talk about hypothesis testing. Hypothesis testing is going to take us through all the way down to the end. And so then we'll have to talk specifically about that because that's going to be the homework which is due on Tuesday. We don't have class on the 4th of July, of course. And so then, just as what's happened previously, on Tuesday of next week, we will go through this information, and then that will be what's on the exam. Then that day, the 9th, which is Tuesday, we'll talk about the next thing, and then we'll have exam number 5, which will cover confidence intervals, and our first topic here having to do with hypothesis testing. For those of you who may not know, I did extend the deadline of today's homework until midnight tonight, so that we can have some extra time to talk about it. And so I want to set up a little bit of context here before we actually get into the problems so that you can understand a little bit more about what is going on with confidence intervals. And we did this already, but just to keep current with what's happening in this situation. When we talk about confidence intervals and we ask the question, why are we doing them? Then it goes to two main ideas, which would be the purpose of statistics, and then also the process of statistics. Okay. How is a confidence interval related to the purpose of statistics? What's the specific connection?
Describe the measure of the population using a sample?
No. Okay, that is the definition of a confidence interval, but that is not what I'm looking for. I did not specifically ask you what is the definition of a confidence interval. I asked you the question, how is the confidence interval connected to the purpose of statistics? So what I would hope that you would do is that you would look at the purpose of statistics, see what's in the purpose of statistics, which is also in the confidence interval. Right? So when you're looking at the purpose of statistics and you have those 4 things that we've gone over every day since the beginning of the term, then when you look at the confidence interval and you say, what's the connection between those 2 things? What do you see in the purpose of statistics that's also something that's in the confidence interval?
Tells you what to expect because you believe the population number is between the 2 numbers and it controls the sample variation.
Okay, that's close. When we say what to expect, what do we mean?
Below 5 or above 95?
Okay, how is that related to what the confidence interval tells us? When you said the confidence interval tells us something about the measure of a population, that's correct. Then there's another little bit of a phrase that I included in there, which I might not have written on the board. But when you think about how to get a confidence interval, is there something about the confidence interval which is the same as when I talk about what to expect?
So it tells us how many people we need to talk to in order to get
No, that's not what I'm looking for.
So does it have to do with the 95%?
Yes. Can I have a 95% confidence interval?
Yes.
Yes. And when I say, what's the purpose of statistics, I'm going to use that 95% in order to say that something is a certain way, right? So that's the connection. When I say the purpose of statistics is to know what to expect, and 95% is a good, reasonable number to use for that, I also use that same number when I'm doing a confidence interval because I want to have confidence about what that thing is saying. And so I'm not going to say, when I do a confidence interval, I'm not going to say I'm 100% sure. I'm going to say I'm 95% sure. Because in my purpose of statistics, I don't try to get exact answers. I try to get things which are most likely to happen. So the purpose of statistics is to not find the exact answer, but to find something that's going to happen 95% of the time. And that's what my confidence interval gives me. It gives me a measure of a population, but I don't know for sure. I only know it for this particular interval, which is what you said. It's an interval that tells me about a thing, but it's not for sure. It's a certain degree of confidence. So when we say the confidence interval gives me a measure of the population, you might add to that with a specific amount of confidence, right? Because that's what it does. It gives you a measure, but it doesn't tell you exactly what it is. It tells you to a certain measure of confidence the interval where that thing is. Okay, now what's the connection of the confidence interval with the process of statistics? It has a little bit to do with the variation, yes.
Control the sample variation.
Okay, we're controlling the sample variation. Why do we want to control the sample variation?
To understand the population.
In order to understand the population. We have the sample. We know the sample is not right or not exact, but because we can control the sample variation, then that means we can actually say something about the population, not just the sample. So the samples are always changing, but if I know how much they are changing, then that means I'm able to say something about the population. Because I can say, I go out, I do a survey, I say, how many people are going to vote for Bernie? And then the Bernie people say, hey, I'm going to vote. And then we say, I know it's just a sample. But because I know how much variation there is, I'm going to say it's 30% plus or minus 4%. Because I can do that. If I have the sample number, that's not the answer, but the confidence interval will tell me how accurate my answer can actually be. So that gives me what I want. Okay. Because the confidence interval is coming from the purpose of statistics and it's coming from the process of statistics, some people say it's the only correct method for statistics. Some people say that when you do confidence intervals, that's the only thing you should do when you do statistics. There are other methods which we're going to talk about. Some people say those don't count because this is so important. It gives us this interval, and so that tells us what's happening. And some people say that's really the right way to do anything at all in statistics. Other people disagree. Traditionally, in the past, confidence intervals have not been the way to do research. Hypothesis testing has been the way. So in maybe the past 5 years or less, the world of statistics has changed tremendously because some people say this is the only way. And there are all kinds of conferences and policy statements and everything like that where people say, don't do hypothesis testing, do confidence intervals. So that's a big change that's been happening relatively recently. But for the past 100 years, people have been using hypothesis testing. And so then when you go out there and somebody says, hey, take a look at this research. Does this apply to our situation? If it's something that's been in the past 100 years and you look at it, they're doing hypothesis testing. But more recent people have been doing this. So it's really important to know how this works and to be able to make this happen with confidence intervals. And then we'll have to take a specific amount of time to actually talk about hypothesis testing because that's what's mainly been out there. But this is a big deal. It's really important. All right. So then, there are 3 types of measurements that we're going to have to consider here. So when we say the things measured, there are 3 of them. What are the 3 things that are being measured?
Proportion, standard deviation.
Proportion, mean, and standard deviation, yes. And what mathematical symbol do we use in the formula and in the table when we're doing each of these things? There are 3 different statistics or formulas or distributions or whatever, tables. And there are 3 different places we look, 3 different statistics that we use. Right? Who can tell me what those 3 things are? All right, you got those?
I forget the specific names, but it's like the little cursive T.
First of all, when we're talking about proportion, is that T?
Yeah.
It's Z. Where's mean proportion? We use Z. So we're going to have Z in the formula. We're going to be looking up things on the table that have Z. Okay. What's next? T. Jessica, what's next? Chi squared. Okay, chi squared. Not just chi, but chi squared. Okay? So, when we get to hypothesis testing, this will also be true. Okay, just so you know. All right. So, in all 3 of these cases, we're going to start with sample information. We're going to include information from the tables having to do with this, and then we're going to put all that together in the formula, and we're going to get a confidence interval. Now, when we look things up on the table, then we need to know for the confidence interval, we need alpha and when we're talking about T and chi squared, we need degrees of freedom. Okay, so when we're asking the question, how am I going to find the numbers that I need from the table? For the z-score, we don't need anything other than alpha. But for looking up things for t and chi-squared, we need alpha, and we also need degrees of freedom. Now, in these situations, we're going to use alpha over 2 since confidence intervals are two-tailed. That's not a really big deal when we look up z, because z only has 3 possible things it could be, so we just use them. It's also not a big deal when we look up t, because t, we just look at the top row, and it just tells us if you have this confidence level, here's where you look. But this is kind of a big deal when we go to chi-squared, because we have to use alpha over 2 on the right, and then 1 minus alpha over 2 on the left, so we have to kind of be aware of how that works. All right, so what I want to do is I want to go through examples of all 3 of these confidence intervals, make sure that things are going decently with all of these things. On the homework, which is going to be due at midnight, it's specifically the finding the sample size and then also doing the confidence interval for the mean and confidence interval for the standard deviation. But I want to go back and review the other confidence intervals as well. So let's say I have 400 people in my survey, 35% support Joe Biden, and I asked the question, what is the 90% confidence interval for the proportion? All right, I'll give you a couple minutes, see if you can make that happen right here. All right, check your neighbor, see what your neighbor has for this. All right. All right. Liz Stanish, can you tell me what z-score you're going to use for this?
1.65.
Okay, 1.65. Liz, can you tell me what Q hat is going to be?
0.65.
0.65? All right. So, Mara, can you tell me what your answer is?
Pass.
Okay. Sierra, can you tell me what your answer is?
I got 0.349 and 0.351.
Unfortunately, that's not correct. Elena Miller, you got some numbers you like?
No.
Okay. Lena Schmidt, you got numbers you like?
I got 0.31 and then
0.31 and 0.39. Yeah, that sounds pretty good. So let's see what we've got here. We've got 0.35 and then minus 1.65 times the square root of 0.35 times 0.65 divided by 400. So when I take 0.35 times 0.65 divided by 400, I get 0.0238 approximately. And then when I multiply by 1.65, I get 0.039 approximately. So then that gives me 0.35 minus 0.04, basically, so that's 0.31, and then on the other side, 0.39. All right, Sierra, does that make sense?
Well, I have that all written down, I just don't know if my calculator's not.
Well, It's really important to be able to get these numbers correct. So what you have in terms of the square root, you've got to be really careful because different calculators work things in different ways. If it has a parentheses that it gives you, okay, then you have to make sure that you don't make parentheses incorrectly in order to get that number which is in the parentheses there after you do the square root is 0.02385.
I get that now, but
Okay.
I have to reset my calculator, I don't know what it is.
385. All right, Mara, is that working for you?
Me?
Yeah.
Yes.
Okay.
So that 0.02385 is what you're getting inside?
No, after you take this, after you take the square root, that's what you get. Lena Miller, does that make sense?
Yes.
Okay. Mariah, did you get that?
Yes.
Okay. Lisa, is that working for you?
Yeah.
Oh, you're getting there, okay. Keep working on it, keep getting there. Question?
In the homework from Excel, when you do the standard deviation, the triangle calculator, there are a lot of choices, and it gives you different standard deviations.
Okay, yes. So that's coming here pretty good. But when we say, what does Excel use for standard deviation? Okay. What I showed you in class was this. It has nothing after that, just that. Okay? And that works. And that's actually from an older version of Microsoft Excel.
That's not an app. It's either AP or something else.
This is the same. Okay? And yeah, I should probably put that into my notes. I apologize because as far as I understand it, this is only a problem on Macintosh or Apple.
It happened on my HP. I just picked one though.
It didn't show up as like the first option on my Dell, but
Right.
then at the bottom it showed it as an option saying that it was for older
Yeah.
Right.
things, yeah.
Yes.
If you click on it, it will go up. Like I clicked on it and then it went up into the formula.
Yeah.
Oh, so that's.
So yeah, even though it says
Yeah.
this is for older, it still shows.
Yeah.
Yep.
You just click on it and it kind of.
Yeah, well, the clouds are all interesting out there, aren't they? Looks pretty interesting. It's supposed to be about 15 minutes or so before it actually gets here. And according to what I have right now, well, I better find out right now. Let's go to the NWS. Where is it? Whether let's click.
So if it's raining times, it's fine, it's just if it's extremely late,
Mhm.
or if they say anything about a tornado, I'm gonna go save my daughter. literally, that's a tornado. I'll just.
Okay.
Yeah, she thinks so.
All right. So, do I have this here? I do. All right.
Just there.
So, no severe weather currently. Yeah, it says don't stay outside. That's what it says. You know, you have a storm coming, which obviously we do. Don't go outside. So yeah, it's very interesting. Nice. And you know, these little clouds on the bottom, they're not really doing anything. It's the ones up on the sky that you have to worry about. All right. So any further questions about confidence intervals for proportion? Okay. So now we're going to change this to be confidence interval for mean. So we're going to have 18 people, and we're going to say how many candidates for president can you name? And we find the mean is 8, and the standard deviation is 4. And so now I want the 95% confidence interval for Krista, why don't you just go ahead and go to save your dog from the weather, because it's going to have a lot of thunder in it. So. Deviations to 4. Five, 6, 7, 8, 9, 10, 11, 16, 17, 18, 19, 20, 21. All right. Was? Musical interlude. Well, because this is going to the first decimal place here, probably 2 decimal places then. Although, really 1 is okay because, it's just how does it affect the number 8? So you really don't need 2. 1. So I'm not sure I have to instruct you to now talk to people around you, but I mean, I will.
I got 9.2, 6.8 is 9.2.
Yeah.
How many decimal places?
All right. Rachel, you got a T value for me? Okay. Chantel, you got a T value for me? All right. Hillary, you got Hillary's got one, don't ya? 2.110, yep. So we're looking up 17 degrees of freedom. 95% confidence interval, you go to that point on the table, 2.110. Okay, does anybody have any question about that T-score? Okay. Rachel and Chantel, you have your T-score table that you're available to look at here. Yeah. It doesn't work if you don't look at the table. That's true. You can't really know unless you actually look. All right, Chantel, you find that number, 2.110?
Yep.
Okay, it's on 17 degrees of freedom and it's under the 95% confidence interval, right? And Rachel's looking right there too.
Right here.
Right there, right there. Okay, so then we need X bar, which would be 8 minus 2.110 times 2.4 over the square root of 18. That would be on one side, and then we would have plus on the other side. So, Melissa, you got a number for that?
6.806 and 9.874.
Okay, and then it's probably okay for us to just go to 1 decimal place here. 6.8 on this side, and then 9.2 over here. Because the question that we're asking here is, how many presidential candidates can people name on average? Somewhere, yeah, 7 to 9. Seems reasonable. 6.806, it's like nobody cares about those decimals, really. They just want a general idea, how many can people name on average? 7 to 9. All right. So, just for the sake of time, we'll just use this problem. And I want the 95 confidence interval for the standard deviation. All right, so it's actually raining now. There we go.
This number. 17.
Lightning?
We have 30.9 or 191. So it's gonna be 30. Get it right. So then we have, we still have 95. This is 95. And on either side we have 0.025, right? We took care of this side. So we're going to this side. We still have on the left side. So we have 95 plus 0.05 to make sure we take so we have 0.95 as 95%. Sure. So that will be 75 story.
I got 125.
That's
All right, so we got to make this happen here. Hopefully you're able to talk to people around you and get ideas about how to make this happen. All right, Abby, you got some chi-squared numbers for me here?
Yeah, 30.191 for chi-squared, right?
Okay.
And I got 7.564 for chi-squared.
Okay. So we're taking alpha, which is 0.05. 95 and alpha is 0.05. Alpha divided by 2 would be 0.25. 1 minus that is 97.5. So we're using these two numbers on the table with degrees of freedom equals 17. Look up those things and put them into the formula. So we're going to have square root of 17 times 2.4 squared divided by chi-squared, right? And then same thing, chi-squared left. Mattia, did you get numbers for the actual left and right sides of that?
Um,
3.25
No, unfortunately, that's not what I have.
I think she did it after you said it.
Did you take the square root on both sides? Oh, yeah, okay, because, yeah, what you probably have is the variance, but if we have to take square root, then that, and so that's not really horribly wrong, it's just a little bit wrong, right? Okay, Mariah, you got those numbers?
maybe, 1.8 and 3.6.
1.8, 3.6, yep. 1.8 over here.
So yeah, we got plenty of lightning for the dog. That's important. Again, as we mentioned previously, this is not symmetric. 2.4 is not halfway in between these two numbers because that's not how standard deviations work. So what we've got here then, when we say, what am I actually talking about? Going back here, what is a confidence interval? It's measuring something about a population. And so, do I know the population standard deviation? The answer is no. But can I locate it with a certain amount of confidence? It's not 2.4. That was just the sample standard deviation. The population standard deviation is between 1.8 and 3.6. Now, for this particular problem, when we say how many presidential candidates can you name? And you say, okay, there's some variation here. Some people can't name very many, others can name a lot. And so how does that translate into the standard deviation? We're not going to worry about that as long as we can get the number to start with. We'll start here. This is what we're getting for the number. But certainly you can think about how would a distribution look like if it has a certain amount of variation. You can maybe graph it out, see how it looks. But it doesn't happen very often. Standard deviations are not as common as doing proportions or averages. All right, so we'll take a break now for 10 minutes. And we'll come back at 1:40 and start in